as well as being able to calculate the expected value of x, or e of x, we can also calculate the expected value of functions of x, like the expected value of x squared, the expected value of 2x, and so on. And in order to do this, all you need to realize is that it's easiest to look at the example here. If we look at the original table here, we have the discrete random variable x, which can take values of 1, 2, and 3, and the probability of each of those values is 0.1, 0.4, 0.5. Notice we sometimes shorten the probability. We sometimes, instead of writing the probability that big X equals little x, we sometimes just shorten that to little p of x. It's just a quick way of writing the same thing, just to explain that in the table. Okay, so the probabilities of each of those values of the discrete random variable are 0.1, 0.4, and 0.5. Let's say we then wanted to work out the probability distribution table for 2x. Well, all we do is we double the values of x to get 2, 4, 6. The probabilities don't change. They stay as 0.1, 0.4, 0.5. And if we wanted to do a probability distribution for x squared, then we square each value of x to get 149. Probabilities stay as 0.1, 0.4, 0.5. Now, the last one there is particularly important because it's used in calculating the variance. Okay, so if we look at the last table, if we want to work out the expected value of x squared, then we just do the sum of each value of x squared multiplied by the probability of each of those. Okay, I'm just going to call it p because it's easier. Let's call it p of x. So all we do is 1 times 0.1 plus 4 times 0.4 plus 9 times 0.5. Okay, and that's going to give us 0.1 plus 1.6 plus 4.5, well, that's about 5.5, 6.1, which is 6.2, isn't it? Okay, so that would be 6.2. Now, that by itself doesn't mean anything, but it is very important when you're calculating the variance. Okay, we'll come back to that later. Right, just to check that you've understood that, I've got one more little example of that. So let's have a look. Let's say we've got this probability distribution table with values of x. If we want to calculate the value of the expected value of x squared, well, there's no need to actually do the table, is there? All we need to do is, where are we? So we're going to do -2 squared times 0.3 plus 0 squared times 0.6, well, that's just going to be 0, plus 1 squared times 0.1, well, that's going to be 4 times 0.3, well, that's 1.2, plus 0.1, and that comes out as 1.3. Okay, right, so you're going to go on and do an exercise now.